Webdev Samos, and today we'll be solving questions from binary search. Um, yeah, so shall we get started? I'll try to solve one easy, one medium. That would be my target today for binary search, and I'll also try to cover linked list as well because solving just um, one data structure problems is feels a little bit slow to me, and and solving two will give me a good pace of revision as well. So as we do sometimes um, two body part workout, so that's how I'm going to treat it, like that. So I'll be targeting two data structures every single day, and yeah, so that I guess that if we keep doing that, we'll grow in, like we'll be able to solve those questions pretty easily. Mm, let's get started. We, I'll start with guess number higher or lower, which is easy. Let's see what the question says, and if we are able to solve it in like uh, like less than 30 minutes or so. Um, yeah. So we are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number picked is higher or lower than your guess. You call a predefined API int guess int num, okay, which takes in a parameter num, which returns three possible results. -1, guess is higher than the number I picked. Your guess is lower than I picked. Your guess is equal to 0. Then return the number that I picked. In this case, my n is equal to 10 and pick 6. What is pick 6? I might have missed it somewhere. Okay. We just have given n. Okay, and got it. Return the number that I picked. Got it. And the range of n would be from 1 to 2 raised to 31. Okay. So basically the pick would be between 1 and n. And this is pretty standard, really standard binary search. We can do it, or we can do it, like say 1 to n linear fashion. So that would be O of n time complexity, and but we can reduce it with the binary search, using binary search. So the idea of binary search is always we can take a left pointer, which will be the lowest, or can we call it low and high? I always generally call it left and right, so that I know where I'm traveling. Right is equal to n. It should be n. And yeah, so unless your left is less than equal to right, I guess you have to keep doing this. But I'm pretty sure that this question will always get a number that can be picked. So I don't need to worry about that edge case where I won't find a number that was not there at all between 1 and n. Okay, so I know that. So I can calculate my mid using math dot floor. I can just take mid, whatever mid it returns to me would be I guess I can call it is ans is answer is pick. Let's call it is pick. So is pick will it gives us -1 3 possible result. Pick is equal to let's say we pass to guess whatever our mid was, and then what we do is if our pick was greater than if our pick is equal to -1, then we know we have selected a higher number than what was supposed to be picked. So we know that we want to make now our right is equal to mid -1. Okay, and else what we want else if our pick value was equal to 1, then we know that our left should be moved towards right. So we make it mid +1, and else if else value would be 0, so we can straight away return whatever mid was there. So that will basically signify if we got the right pick, and if everything is okay, we'll get accepted for this guy, and let's submit. So yeah, this was pretty easy. If you generally want to practice your binary search algorithm, then this is the one. So I have done it in past, and now I guess I did it in April of 2022, and yeah, after that I have done it today. So a nice gap between these, and let's see how many companies like to ask question of this sort. Yeah, Apple, Bloomberg, Uber do like to ask this question. uh, yeah, let's let's put this bad boy in our binary search list. Okay, so we solved this in like 6 minutes, and the time complexity is log of n, log n, sorry, O big O of log n, where n is the n that has been given to us, and time complexity, space complexity would be O of n. Yep. Okay, so that is that, and we can go to the practice section. Tick mark this. This is not that important, but we'll just tick mark this question as we have completed it. And single element in a sorted list. So let's do this guy, which is a medium question. Single element in a sorted list, sorted array. I guess I might have done this whenever October 27. Okay, October 27. So I have done it pretty recently. So let's reset this and see what the question is really asking us. You're given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return the single element that appears only once. Your solution must run in log n time and of one space. Okay, yeah, this was pretty tricky question. I remember now, because it was really hard to identify which we if even if we are using a binary sort in this case. sorry, binary search. In this case, it was difficult, like where should we go from here? Should we go to left or should we go to right? Like if we so I definitely must have seen the solution for this one. Let me start the timer, and it was not a long back that I have seen this. So this is a good question to be practiced. 1 1 2 3 3 4 4 8 8. So I have this. Okay, so my left and right would be definitely 0 and the length of nums minus 1. If I suppose, let's say, take the mid, yeah, how will I know basically? Oh yeah, yeah, okay, okay, I got it. I got this one. um Basically what I need to do is, whichever part is, I need to check which part of this is odd length and even length. Yeah, yeah, that's what I have to do. That's, I guess that's what the logic is about doing this. Because let's say, um, if you have been given this one, so this length is 0 1 2 3 4 5 6 7 8. So 9 is the total length of this array. And if we, let's say, 0 8 divided by 2 4 0 1 2 3 4, this would be the mid of the mid of the, what would you call it, of the array. And then what we have to do is basically see if which part is this equal to, like if 3 is equal to here, or 3 is, yeah, this is a pretty complex question. This like this should be categorized under a, under what, under a hard question, I believe. But let's say because there are many edge cases that you have to consider when solving this question. Let me jump onto my Miro board and hopefully we can still solve it. Okay, and um let's reload this guy. Let's see if reloading it makes any change. Okay, give me 1 second, I'll just get rid of whatever is on the screen and we'll start fresh. Okay, is it working? Oh yeah, yeah, it's working. So I'll go back and just note down what the array is signifying. So 1 1 2 3 3 4 4 8 8. Okay, so I have this with me. I will just name this 0 1 2 3 4 5 6 7 8 nums. Okay, so we find out the mid. So there would be a case where this mid is not at all equal to um, to both of its right left and right. So in this case, that would be our answer. That would be the single guy that we were looking for, right? Okay, but we have to check for other cases. We know that wherever there is a discrepancy, like everything would be um, 1 1 2 2 3 3 4 4 8 8, it would result out in an even length, right? Yeah, it would result out in a even length array. So if you see 1 2 3 4 5 6 7 8 9, so this is a 10 length array, this is a 9 length array. We know that, so we can take the advantage of that. And how should we proceed it? So my medium, I know that I'll be happen to be hopping on this particular number. Then it's up to me where I should be going from here. So how can I do that? Can I just see if my left to the right, this guy, yeah, can I see if my left to right, what length I'm getting? So this length would be odd one, which is 5. This is odd, and from this guy, basically both will be odd. So yeah, there is two possibilities. I have to basically consider either it can be on left or either it can be on right. So what I will do is I will also check what is I will check, this is the one part I'll check, and this is the other part I will check. Okay, and this turns out to be an even length of 4, even. But what if there was a scenario where our single element was here on the right hand side, in this side? What would we have done in that case? So we have to consider that uh, the the number that we are looking for can also be in this area, in this guy's, mm, or or we can basically check if my mid, like I'm just thinking, if let's say I check this also, and I checked for I'll change the color, and I checked for, I won't take the mid, I will take just this will be 4 length, and the next one I will take is from, so this would be from 0 to 3, and this would be from 4 to 8, okay, which will be 5 odd length. What so we cannot go in both of them and try to see, because that would be basically um, searching for the element in two places. We want to just select one guy and keep moving in that direction. We don't want any other thing to be happening. So what should we be doing here? Should we be checking which part is equal which part is having the 8, or let's say the single element? How will I know? So if my mid is there, I check my left, check my right, it is not equal. So basically I guess I need to come up with some edge cases. Let's say 1 1 2 2 3 3 4 8 8. Okay, 0 1 2 3 4 5 6 7 8. So our mid would be this guy, and in this case our we found a guy in this area, in this one. Okay, and we check that, check uh, check the length of this. So 4 to 8 is 1 2 3 4 5 5 5, which is an odd, and this guy is even. Obviously, yeah, we have to search in here, but okay, yeah, I guess we have to just check where, if I'm remembering it right, it was pretty complicated than what I'm doing here. So let's see how it turns out to be. So I have my left pointer, left is equal to 0, right is equal to nums dot length minus 1, and till what point we have to do it? Yeah, I guess we have to do it till left is less than equal to right. And what we'll do is let mid is equal to what we have to check is we need to go to floor and we need to find what was the mid. Let's make it bigger so that we can just focus on our code. Yeah, you can so yeah, here we have our mid with us, and now I have to check my left hand side and my right hand side, so where it might be. But the thing is, I might be, if I mid minus 1, if it is going out of bound, I don't want that to happen. So do I need to check if I do mid minus 1, is it going less than 0? Yes, I probably should need to check that. If my mid minus 1 is greater than equal to 0, and then mid plus 1 is less than equal to nums dot length minus 1, then I know I'm doing everything in bounds, right? Okay, so what I need to do is this would be my main condition for me to do other operations. So yeah, I know now I am whatever I'm doing is in bounds, so I need to check if my left and right are equal. Check if your left and check if your left or right is equal to you. So if mid nums of mid plus 1 is equal to nums of mid, okay, So that means that we we have an odd length. Okay, and now, yeah, it can be a possibility that, so how can I create a possibility? Let's say like will there be a possibility where my I was just thinking if I guess I will always find a number. What I was thinking is basically if I find out my mid nums of mid, like I'll just write it for better understanding. Equals to, I'm just trying to understand if my nums of mid, let's say it's equal to the guy at right. Okay, this is my right. So now what I need to check is what is its length, right? What is the length on the right hand side? If it is if it wow, why is my camera not responding? Really? Something has gone wrong with my camera. It's not ready to start. Okay, it started. Cool. Like it was just turning off by itself. I guess I sometime in some point later I will invest in a camera so that it doesn't turn off in mid of the stream. Okay, where were we? We wanted nums mid equal to nums mid plus 1. Now we want to check if my length towards right is, but isn't this going to be too complicated? Yeah, there is a possibility. Okay, let even length is or why don't I find out, instead of doing all of this, why don't I just is even length so from mid so if I find out which side is mid length, so okay, is right even, is right even let's check if our right side is even or not, from the mid. From the mid. Okay. So mid, whatever mid we had, mid till plus right, so 4 plus 8 mod, so 4 plus 8 would be 0 1 2 3 4. 4 plus 8 would be 12. 12 by 12 mod 2 would be 0. That is not what I want. So 4 plus 8. Okay. Minus 1. I guess we have to do this mid minus 1 but mod 2 will let us know if right is even or not. Okay. And if right is even, if is right even equals to 0, else it is not even. And when it is not even, then our answer would lie in the else part. Right. I'm just going in a spiral. It's been 15 minutes, I guess, and it's not taking me anywhere. So let's just look at the solution. I see I have, what I did at that point was just I might have looked at the solution. Oh, so we did do that. If right is even, then we checked if our mid plus 1 is equal to mid. Then if right is even, then left is mid plus 2. Okay. Else if right is not even, and this is pretty hard question. I wouldn't say that this is easy, and a lot of companies like to ask this question. So I guess could we just go through the editorial once? Let's try to sit and understand what's going on here. Okay, let's just read through the editorial once. Okay, let's take our time. Let's sip some water and just sit through this question. Let's see what's going on. So it's I guess it's all about understanding how various edge cases are working. If I go to description 337 10 11 11. Okay. Okay, let's not waste any time further. Let's not waste more time and get to it. So the brute force, we can use a linear search to check every element in the array until we find a single element. Yeah, that's true. We can just keep on going, and that would be O of n, that I know. So binary search, what it makes sense to try and convert the linear search into binary search. In order to use a binary search, we need to be able to look at the middle item and then determine whether the solution is the middle item or to the left or to the right. That is true. The key observation is to make that the starting array must always have an odd number of element, be odd length. Yeah, because it has one element appearing once and all other elements are appearing twice. Here is what happens when we remove a pair from the center. We are left with left subarray and right subarray. True that. Okay. So, like the original array, the subarray containing the single element must be odd length. Yes, the subarray not containing it must be even length, right? So, by taking a pair out of the middle and then calculating which side is now odd length, we have the information needed for binary search. Okay, let me go to my board. And whatever mess I've created, let me rub this out. Okay, looks like this is not refreshing. Okay, so we have our guy ready now. So yeah, our mid is this guy, right? And according to the algorithm, we checked from mid to the right if it is, what is its length, what is its length here. It looks like it's giving us an odd length from 4 to 8. It will be odd length, and this is giving us even length. Oh, sorry, this one is giving us even length. But the thing is, we were told that um, that the single number will be always onto the odd side of odd side. Yeah. Okay. So what we have here, the information that we have is, we know that our right side is not even, right? So we need to check if where does it equals to this 3 that we are pointing at, if it equals to the +1 or -1. So we check that it falls under, like it matches to the other side, like if we do mid -1, then it matches. Then we check if our right was odd or even. If our right was odd, let's say if our right was odd, then okay, but we found we found out that mid minus 1 is equals to here. In mid minus 1 was the guy where we find our mid, and if right even, if right is even, then we want our left to shift to mid plus 2, mid plus 1, sorry, mid plus 1, and else we want our it right to move mid plus 2. Okay, and what if the case was different? I mean, what if we didn't have this oops, just have this guy here, and we can make this 2. So this was odd length, and we found out that our matching one is at mid plus 1 is where we found the match. Now we see if is right even, no, it sorry, if right is even, no, it is not. So which means that our so our left would be equal to mid plus 2, else our right, if our right was not even, then mid minus 1, right? Yeah, that's what we have to do. So for in this case we had 4 here, and this was this is odd and this is even, but we found a match in this guy. So we'll move our left pointer left would be mid plus 2, right? So left would be here and right would be here. Then what we'll do is we'll find out the mid of these two guys, which will be this guy. Mid would be this. Then we check if mid to right is odd or even. That is even, and mid and this guy, sorry, yeah, that is even. So what we do is we check where this condition falls. So the mid matches to its partner at this guy. Okay, now we will check if right is even. Yes, it is even. Yeah, but how do you, okay, so yeah, yeah, so this is what we did. This is what, oh, if mid minus 1 equal to then halves are even, mid minus 2. Okay. Else okay, return nonce of flow. Okay, let's do one thing. Instead of I'll just go over the approach here, algorithm. We start by setting low and high to be the lowest and highest index of the array. Then iteratively half the array until we find a single element, or until there is only one element left. We know that if there is only one element in the search space, it must be a single element, so should terminate the search. On each loop iteration, we find the mid, determine the odd evenness of the sides, save it in a variable halves are even, by then looking at which half the middle element partner is in, either the last element in the left subarray or element or first element in the right subarray. We can decide which side is now or remained odd length and set low and high to cover the part of the array we now know the single element must be in. The trickiest part is ensuring we update low and high correctly based on the value of mid and halves are even. These diagrams should help you understand the cases when solving problem like this. It's often good to draw a diagram and think really carefully about it to avoid by one error off by one error. Avoid using a guess and check approach. Yeah. So mid partner is to the right and the halves are originally even. So mid was here. So from 0, 1, 1, 2, 3, 4, 5. This was even. So my low should be, so my right was not even. My right wasn't even. And I found my mid, I found that my mid was equal to like when I plus it, it was equal there. Then I come in to this guy. If my right was even, if my right was even, if my right wasn't even, then I know the element is on to the right hand side. So I need to skip. Left would be mid plus 2. That would be the new low. Okay. Okay, that is that. But what if my right was even? Then what I need to do is mid my high would be mid minus 1. Is this what happening downstairs? Yeah. So if my halves, if high minus mid mod 2 equal to 0 is what we are checking. If my what we are checking here, high minus mid would give us the right portion, right? Whatever the right is consisting of, it will give us that, isn't it? So even if we consider that 0, 1, 2, 3, 4, 5, 6, 7, 8, and our mid is, sorry, 0, 1, 2, 3, 0, 1, 2, 3, 4, 4. 8 minus 4 would be 4. 4 mod 2 is equal to 0. So my this guy is even. How can it be even? I don't exactly get it. Let's check it in Python. Like, is it what I have implemented earlier? If right minus mid is right even. What am I missing here? I'm not kind of getting it. If right is even, then how can the answer be there? Right should have been odd for the answer to be there, right? So that's why we'll search in. We need to be able to look at the middle item and then determine whether the solution is in the middle item or to the left or to the right. The key observation to make is that the starting array must have an odd number of elements, because it has one element appearing once, all the other. Yeah, so that is okay. Here is what happens: we remove pair from the center. We are left with left sub array and right sub array. Okay, that is totally fine, whatever it is. If the original array, the sub array containing the original if the original array, the sub array containing the single element must be odd length, the sub array not containing it must be even length. Yes, that is true. So by taking a pair out of the middle and then calculating which side is now odd length, we have the information needed for binary search. That is true. That is what I am saying. In this case, so instead of finding, so why are we doing this? I'm not understanding that. Like high minus made by 2. And even if we do this, then if my mid plus 1, like in this case my mid is equal to plus 1, and then my search would be in this space, right? But if I calculate it from here, like from this mid, it looks even to me. Like it basically looks even to me. Sorry, odd to me, because 8 minus 4 would be 4 and mod 2 would be obviously 0. So why these guys are doing it this way? Because this should have been the other way around. Let me just check whatever the logic that I've written. Let me just grab this. This question has taken a lot of time. a lot of time. Okay, so is right even? I'm checking this if my right is even. So if my right is even, if my right is even, then I know that my answer let me guess what's happening here. So if my right is even, let's say, but they should have, what they should be doing is they should be doing this like -1, and if my right is not even, this should be happening. Okay, yeah. Now I'm kind of getting it what's going on. So this logic makes total sense to me. Like what what they are coding out is not what is entirely, I'm sure, but yeah, let's see. So the logic is like as they specified in the editorial, whatever the even, whatever the odd side is, that's where our answer lies. Okay, so if so what we are checking is if our right side is even or if our left side is even. Okay, oh sorry, if our right side is even, we are checking here. And let's say our mid is we found that our mid is towards the right side, and we found out that our mid is not right, right is not even, then it totally makes sense for me to say that my as my right is not even, then I should move my left pointer. This is totally getting weird. Okay, yeah, so where were we? We were, yeah, is, so it totally makes sense for me to move my left towards the right because I know that my right was not even, it was odd. So I should be searching in my right space. So that makes sense to me. Else, else my right is even. So that doesn't make sense to search in that space. So what I'll do is, as I have found that mid plus 1 is equal to the mid, so I need to -1 the mid and search in the left, bring my right to the left portion where my, yeah, so left and mid would shrink. Else if, yeah, this totally makes sense to me, other than like rather than what the solution that they have provided is totally like the wordings and what they have coded out was not, was not matching up. This is actually matching up, and I guess if I just if I just provide some comments to this question, then I would be able to recall it later on. Check for the check if the the gist of the question is whichever side is odd length, the answer should be searched in that space let's say in that particular space we have to search the answer, and also make sure to account where the mid is matching and move the point left and right pointers accordingly. Okay, so yeah, that's what I'll be doing. Cool. Okay guys, that is it for this one. This is um, pretty complex one. I guess I have star marked it. Let me go to my list of questions that I must revisit and note this question down, because this is really important one. I can't emphasize enough on this question. So let's see. Yeah, I am on this one. Let me so which list I'm maintaining actually, because I kind of created two lists, and okay, binary search, and what is this question? 540 single element in a sorted array. Single element in a sorted array. That, and let me mark it as very important. Cool. So doing such questions really expands our thinking about how we can actually implement binary search. So yeah, that is it for this one. I guess I should now mark this question and star mark this, and the next time we come around I want to solve some other questions as well. And as the time goes by, and if we are able to solve good amount of questions, then I'll uh, try to squeeze in 3